So when you hear the word matrix, you may think of a lot of different things, but it is just a rectangular array of numbers. Each number in the matrix is called an element or an entry. And so they give this example right here. This is a matrix. Couple things that you want to know about matrices. They are named with capital letters. Inside the matrix, we're going to have some lowercase variables, but matrices are always labeled with capital letters. The elements are arranged in rows and columns. So your rows run this direction, right? These are your rows. Your columns, just think of like a column on a house. They run up and down vertically. Okay, that's important because when we start doing matrix multiplication, how you arrange them is important. Dimensions, they do have dimensions. The dimensions of the matrix are listed with a little X, like you would think of dimensions of anything if you've ever had dimensions of a room or anything like that. M represents the number of rows and N is the number of columns. So when you list the dimensions, you would list rows first and then columns. So for this particular one, you would say that M is a 2 by 3 matrix, all right? And then some notation for that, you can see that you have the capital letter M and a little 2 by 3 underneath it. That just tells you the dimensions of that particular matrix. Matrix also, when you're just listing the elements, you have brackets here. The brackets are closed, open brackets where they almost look like absolute value signs without that little clip at the top of the bottom. That actually means something else for matrices. And so when you're writing out a matrix, you have the little dash at the top of the bottom to indicate you're just giving me the elements, all right? So let's look at some of the things you do with them as far as just recognizing the different pieces of it. This says state the dimensions of each matrix. So if I were to state the dimensions, I would say my rows and then my columns. So this would be a 2 by 2. So the dimensions here would be 2 by 2. If I looked at this, I have 1, 2, 3, 4 rows and 3 columns, so 4 by 3. This is a special type of matrix. This actually only has 1 row and 4 columns, and this is called a row matrix. So when you have just 1 row, it is a row matrix. This one actually is a 3, so 3 rows and 1 column, and so this is called a column matrix. By the way, this guy is called a square matrix. I don't think they define that right now. Oh yeah, they do. A square matrix. Anytime your dimensions are the same, it's a square matrix. That makes sense, right? Because dimensions of a square are the same. So you have some special cases here. A, C, and D are all special types of matrices. All right, let's look at the elements. Look at example 2. So each element is named. This is not 11, 12, 13. It looks like it, but this is actually telling you where you are. So this is telling you the row, and this is telling you the column that you're in. And so if it asks for a specific element, it's going to list that. It's going to say, I want this specific element. And it's actually telling you to go to that row and column that it's telling you to go to and give back the element that's in it. So if you look at the top, page 147, it says state the value of each element. This right here is asking for row 1, column 1. And so if I were to give that element, I would go to row 1, column 1, and I would see that element is 3. This one here, row 2, column 3. So I'm going to go to row 2, third column, and I'm going to get a 14. And so that's how all of these would do. Row 4, column 4. That's going to give me the 8. Row 3, column 1. That's going to give me a 12. All right. And so how this is actually used sometimes in word problems. Very often they like to use it in standardized tests as well. But one of the key things you'll see is they love bar charts, right? They love interpreting these. And so very often they will interpret a bar chart with a matrix because then they'll do something else with it to quickly find information. And so you can see that they listed their rows as the months. So we have January and February. Those are the months. They've color coded them. January's are the blues. February's are the reds. And so those are my rows. And then my columns are my weeks. Week 1, week 2, week 3, week 4. And so we have our week 1, week 2, week 3, week 4, right? And that's the actual bar graph piece of it. And so then they just said, well, in week 1 in January, what did I have? Well, I had 5. In week 1 in February, what did I have? Well, I had 6. And so they've just listed this with the different weeks that match up to this bar chart. And so then what happens with a bar chart, that's fine. But then when you put it in a matrix, you can very quickly see either a trend or something like that, or very quickly pull an element that you need. And then sometimes you actually, we're going to get to multiplication. You can then multiply it by something to quickly get information on what happens if all of these are multiplied by something. And so very often they'll convert one to the other, either bar chart to a matrix or vice versa. All right, let's try some of these. They've given us this matrix here. They want us to state dimensions, number of elements, list these elements, actually list the label for these elements and list the elements that go with those labels. Matrices can represent data. They can also represent figures on a coordinate plane, all right? And so when you have figures on a coordinate plane, which I think we did a little bit of this in geometry, your first row represents your x coordinates and your second row represents your y coordinates. So you can actually plot them based on what they've given you. And so A is actually the point 0, 0. You just read it down. And so if I wanted to plot that point, I would go to 0, 0. That would be my A. The next one would be 2, 3. So 2, 3 would be my B coordinate. 5, 2 would be my C coordinate. 4, negative 3, D. And then 3, 1 would be E. All right. And so then you just actually go in order that they've given it to you if you want to see what figure you have. So for this one, you're going to go from A to B, right? And then from B to C, just like you would if you were doing connect the dots, right? And so that would be your figure on a coordinate plane, all right? And this is what we did in geometry where we translated them, where we slid them around the graphs and reflected them and rotated them using matrices. You can do that with a matrix as well.